The heat wave dominating headlines across the world right now is already dying down. That's not the story. What's quietly building behind it, deep beneath the surface of the Pacific Ocean, is why climate scientists are watching their monitoring screens with genuine unease. As of last month, NOAA didn't forecast this, they confirmed it. El Niño has officially formed, and multiple independent models now put the odds of it strengthening into a Super El Niño by winter at roughly 2 in 3. Some of the temperature tracking maps used to chronicle heat records are already running out of colors to represent what comes next. Here's the mechanism driving all of this, and once you understand it, the rest of this story clicks into place fast. It's called the El Niño Southern Oscillation. ENSO for short, a natural cycle that swings the tropical Pacific Ocean back and forth between two opposite states every few years. La Niña, the cooler phase, happens when sea surface temperatures across the central and eastern Pacific drop below average. El Niño, its opposite, is when those same waters heat up well beyond normal. Under typical conditions, trade winds blow steadily east to west, pushing warm surface water toward Asia, while cooler water rises up from the depths near South America. During El Niño, those trade winds weaken, sometimes even briefly reversing direction, letting warm water that would normally stay pinned near Asia slosh back eastward across the entire Pacific. Because oceans store heat far more efficiently than the atmosphere does, that shift in surface water temperature creates an outsized ripple effect across the whole planet's weather, not just the region immediately around the Pacific. For the past couple of years, the planet has been sitting in a weak La Niña pattern, the cooler half of this cycle. And even then, this year still produced record-breaking heat waves across Europe, brutal heat domes across the United States, and extended heat alerts covering well over half the American population at various points. That already tells you something important. The baseline global temperature has climbed so much that even the cooler phase of this natural cycle is still producing historic, dangerous heat events almost every year now. As of NOAA's June 11th announcement that La Niña has now officially collapsed. El Niño advisory status is in effect, with the Climate Prediction Center putting the probability of El Niño persisting through winter 2026 into 2027 at 96 to 98%. A downwelling Kelvin wave, essentially a massive pulse of warm subsurface water, has already propagated eastward across the equatorial Pacific, with subsurface temperature anomalies reaching as high as 8 degrees Celsius above normal between roughly 50 and 250 meters deep. That warm water is now surfacing in the eastern Pacific, actively fueling continued surface warming. Forecasters also point to a rare triplet of tropical cyclones in the western Pacific earlier this spring that produced unusually strong, sustained westerly wind bursts, mechanically pushing warm surface water eastward, a known precursor signal that often shows up ahead of the largest El Niño events on record. Here's why this matters more than most people realize, because of one simple, well-documented historical pattern. Some of the hottest years ever recorded on this planet did not happen during La Niña. Years, they happened during, or in the year immediately following, a strong El Niño event. The extremely strong El Niño of 2015 into 2016 helped push 2016 into the record books as one of the hottest years ever measured at the time, a record that stood for years afterward. More recently, a strong El Niño developed through 2023, and 2023 went on to break the global temperature record outright, only for that record to be broken again the very next year, in 2024, as the lingering warmth from that same event continued working through the climate system, even as the ocean cycle had already begun shifting back toward cooler conditions. This isn't a coincidence that happened once or twice. It's a pattern researchers have documented across multiple El Niño cycles going back decades, consistent enough that climate scientists now treat an incoming strong El Niño as a fairly reliable early warning sign that global temperature records are likely to fall within the following 12 to 18 months. Now, let's talk about those maps, because this is where the story gets visually strange, in a way that's hard to unsee once you notice it. Weather and climate agencies worldwide use color-coded temperature maps to communicate forecasts and records to the public, running from cool blues up through yellows, oranges, and deep reds to represent extreme heat. For most of modern history, that scale was more than enough. Red at the top end represented the worst-case scenario, temperatures considered almost unthinkable. That stopped being enough a while ago. Back in 2013, Australia's National Weather Bureau had to literally redesign its own forecasting charts, adding brand new colors, deep purple and pink, specifically because the country's temperatures were pushing past 50 degrees Celsius, a threshold the original color scale was never built to display. It wasn't a symbolic gesture, it was a practical necessity, because the existing chart simply couldn't visually represent numbers that high. That same pattern has been repeating worldwide ever since, with meteorologists covering historic heat waves across Europe and the United States, introducing darker and darker shading at the top end of their maps. because traditional bright red was no longer sufficient to visually separate a bad heat wave from a genuinely unprecedented one. When a graphic designed to represent the worst possible heat starts needing brand new colors just to keep functioning, that's a direct physical sign that the range of what counts as normal has shifted. If you're the kind of person who wants to actually understand what's happening behind these headlines, rather than just reacting to another scary chart, that's exactly what this channel is built around. So go ahead and subscribe if you haven't already, since this transition is only just getting started. Now, let's get into why the incoming El Niño specifically raises the stakes on this pattern even further. During El Niño years, the tropical Pacific releases an enormous amount of stored ocean heat directly into the atmosphere. Heat that had been building up beneath the surface during the preceding La Niña and neutral phases. Multiple independent long-range forecasting models covering this transition are already showing strong, consistent agreement, which climate scientists treat as a high confidence signal rather than a shaky, speculative one. This kind of model agreement matters enormously in seasonal forecasting, since any single model can occasionally produce an outlier result based on its own particular assumptions and limitations. But when institutions using entirely different data sources, different computing approaches, and different research teams all independently converge on the same basic outcome, forecasters treat that convergence as a far stronger signal than any one model could provide alone. As of NOAA's most recent diagnostic discussion, forecasters put the probability of El Niño strengthening through the end of the year at 97%, with roughly a 63% chance that sea surface temperature anomalies exceed 2.0 degrees Celsius in the Nino monitored region, the specific threshold NOAA uses to classify an event as a very strong El Niño. If that pattern plays out the way current models suggest, the practical everyday impact is fairly straightforward, even if the underlying ocean physics are complicated. Regions already struggling with dangerous heat this year could see conditions intensify rather than ease once El Niño fully takes hold, particularly heading into next summer. El Niño and La Niña don't just change how hot the planet gets on average. They also reshuffle exactly which regions bear the worst of it. Parts of the southern United States, which often experience drier conditions during La Niña, frequently see wetter patterns return once El Niño develops, while the Pacific Northwest and northern tier of states, which tend to see wetter La Niña winters, often swing toward warmer and drier conditions instead. El Niño years have also historically been associated with reduced Atlantic hurricane activity, since the stronger upper-level winds that come with El Niño tend to disrupt storm formation, even as they simultaneously raise the odds of drought and wildfire risk in parts of Australia, Indonesia, and southern Asia. Regions that depend heavily on rainfall patterns, El Niño tends to suppress. There's an important distinction worth making here, because it separates a solid, evidence-based explanation from pure fear-mongering. ENSO cycles are completely natural. They've been swinging back and forth between El Niño and La Niña for as long as scientists have been able to measure ocean temperatures, long before industrial greenhouse gas emissions became a factor at all. Nobody is claiming El Niño itself is caused by climate change. What climate scientists are pointing to instead is the way this entirely natural cycle now operates on top of a planet that's already roughly 1.25 degrees Celsius, warmer on average than it was before industrialization. Picture a swing set installed on a floor that keeps slowly tilting upward year after year. The swing itself still moves back and forth exactly the way it always has, following the exact same natural rhythm. But because the floor underneath it keeps rising, every single arc of that swing now reaches a little higher than the arc before it, even the ones that are technically on the cooler, lower end of the natural cycle. The natural swing hasn't changed. The baseline it's swinging on top of has shifted upward. And that shift is precisely what keeps pushing supposedly ordinary El Niño years into genuinely record-breaking territory. It's worth putting this incoming event in historical context, because not every El Niño reaches the same intensity, and the difference between a moderate event and a genuine Super El Niño matters enormously for how much global temperatures actually move. Scientists generally classify an El Niño as strong once sea surface temperature anomalies in the Nino 3.4 region, the specific patch of central equatorial Pacific used as the standard monitoring zone, reach at least 1.5 degrees Celsius above average. The three strongest El Niño events on modern record, 1982 into 1983, 1997 into 1998, and 2015 into 2016, all pushed well past that threshold. And all three were followed by significant global temperature spikes and major disruptions to weather patterns worldwide, including severe droughts across parts of Africa and Southeast Asia, and unusually intense winter storms hitting the western United States. If current forecasts hold, and this event does cross the 2.0 degree threshold NOAA uses to classify a very strong El Niño, it would place this event in genuinely rare company, among the small handful of the most powerful El Niño events ever directly measured. There are also real, tangible economic and agricultural stakes tied to an event of this scale beyond the temperature records themselves. Past strong El Niño events have been associated with reduced agricultural yields in specific regions, particularly sensitive to the rainfall shifts we described earlier, including palm oil production in Indonesia and coffee and cocoa crops across parts of Southeast Asia and West Africa, regions where El Niño tends to suppress the rainfall those crops depend on. Coral reef systems are also particularly vulnerable during strong El Niño events, since the additional ocean heat released during these events can push already stressed reef systems past the temperature threshold that triggers mass coral bleaching, a pattern documented during both the 1997 to 1998 and 2015 to 2016 events. None of this means every single one of these specific impacts is guaranteed to repeat identically this time. Every event has its own particular characteristics, but these are exactly the kinds of downstream effects that agricultural forecasters, insurers, and resource managers are already factoring into their own planning as this event continues to develop. None of this means every single day for the next year will be unbearably hot everywhere at once. Weather remains messy, regional, and full of short-term variability that no single ocean pattern can fully control. Some regions could genuinely see relief from certain conditions, particularly places that benefit from the specific rainfall and temperature patterns El Niño tends to bring. But on the scale that actually matters for tracking global climate records, the yearly average across the entire planet rather than any single storm or single city's forecast, the transition currently underway in the Pacific is one of the more significant, well-forecasted shifts scientists have flagged in years, precisely because so many independent models are agreeing on the same outcome using different methods and different data sources. It's also worth understanding how forecasters actually detect a transition like this one before it fully arrives, since this isn't guesswork based on surface temperature alone. Beyond the subsurface, Kelvin wave and westerly wind burst signals we mentioned earlier, forecasters closely track something called the Walker circulation, a massive east-to-west atmospheric airflow driven by the temperature and pressure difference between the warm western Pacific and the cooler eastern Pacific. Under normal conditions, the circulation reinforces the standard trade wind pattern, helping keep warm water pinned near Asia. When that circulation breaks down, allowing warmer water to shift east toward South America, NOAA treats that as one of the defining signals confirming an El Niño has actually formed, rather than just been forecasted. Combining this atmospheric signal with direct subsurface ocean temperature readings and satellite sea surface measurements is exactly what allowed NOAA to move from an El Niño watch to a full El Niño advisory this past June, upgrading their confidence level based on multiple independent lines of physical evidence converging at once rather than a single data source. So here's the honest, complete picture, without exaggeration and without downplaying it either. The heat wave dominating headlines right now really is likely to ease as the current weather pattern breaks down, exactly the way any individual heat wave eventually does. But underneath that short-term relief, a much larger, slower-moving shift is already confirmed underway in the Pacific Ocean, one that NOAA and multiple independent forecasting centers now expect to bring a strong, quite possibly super El Niño event by winter, and quite possibly the hottest global temperatures this planet has directly measured in modern record-keeping. The maps used to track these temperatures keep needing new colors for a very simple, unglamorous reason. The old colors were built for a version of this planet that no longer fully exists. It's not one dramatic, sudden event pushing these charts past their limits. It's a slow, steady, well-documented climb, one El Niño and one La Niña at a time, each cycle landing on a slightly higher baseline than the one before it, until the tools built to track it simply can't keep up anymore without being redesigned. Whatever color eventually gets added next to represent the following record, the underlying story behind it will still be the same one we just walked through. A natural ocean rhythm running on top of a floor that keeps quietly rising. We'll be tracking every update as this El Niño event continues developing over the coming months, since this transition is only just getting started. If breaking down what's actually happening behind viral weather headlines is the kind of content you want more of, a like and a subscribe genuinely helps this channel keep making it. Thank you for watching, and I'll see you in the next one.